Good morning, ma'am. My name is B. Ramu. I'm from 7th semester ACEB section from Institute of Aeronautical Engineering College. I'm going to give a presentation on the topic of successive approximation of analog to digital converters, which is also called as a successive approximation of ADC. Unlocking the digital world, an in-depth look at the successive approximation ADCs. So we can see the introduction of successive approximation of ADC, a fundamental component in the realm of electronics that bridges and the gap between the continuous analog world to the discrete digital processing. The SAR, which is also called as a successive approximation. The SAR ADCs are a cornerstone technologies enabling countless modern devices to interpret and utilize real world signals from the touch of screen. The precise measurements in the industrial control systems. This presentation will develop into the intricate workings and advantages and board application of this indisplainable circuits, highlighting why they are remaining a popular choice of many demanding scenarios. The SAR is architecture as well as the key components. Now we will discuss. At the heart of every SAR ADC lies a carefully orchestrated an arrangement of electronic components, each playing a crucial role in the conversion process. Understanding these individual blocks is essential to grasp how an analog voltage is meticulously transformed into a digital equivalent. So there is a different stage to convert analog into digital. The first stage are sampled and hold circuits, which is also called as SNH circuits, and SAR successive approximation register, and digital to analog converters ADC and comparators. While coming to the SNH circuits, its initial stage acts as a snapshot mechanism, capturing and maintaining the instantaneous analog input voltages from the duration of conversion. Without this, varying a input signal would corrupt the SAR process, leading to inaccurate digital outputs. It's ensure a stable voltage is presented to the comparator. And coming to the SAR is a brain of operation. The SAR is a digital register that orchestrates the bit by bit approximation. It generates a digital code starting with the most significant MSB bit and adjusts it based on the comparator feedback. This iterative process is what defined as the approximation. So coming to the DAC. DAC is a digital to analog converters. It's a inverse of ADC. The purpose of this, within this architecture, it takes a digital code and digital code from this SAR, converts into a precise analog voltage. For the purpose, we need to use a DAC. And coming to the comparator, it's serving a decision maker. The comparator is a ultra fast differential amplifier. Its primary function is to compare held an analog input from the SNH circuit with the analog output voltage from the DAC. Based on this comparison, it sends a binary decision high or low back to the SAR, guiding a next approximation step. So there is a working principle and conversion algorithm. So the working principle is mainly five stages: installation of a SAR, a DAC, conversion and comparison, bit decision logic, and iterative binary search, and finally digital output. Let me explain what is what. The first one is installation of SR. The conversation of processing begins, whatever the process, it begins with this stage only. So the SAR is a typically uh, whatever the MSB bit is the given based on the digital output is set to the 1 in first stage. So whatever you are getting any output, the MSB bit is set to the 1 and other bits is set to the 0. So this is the initial step. And coming to the DAC conversion and comparison, the digital value of SAR fed into the DAC. Whatever we are getting the output, that can be fed into the DAC. So the generative of DAC corresponding their analog voltages. The DAC output voltage is in compared again is the SNH input voltage in a high speed comparator. So it's nothing but when we give an analog voltage to the DAC, it will generate a input. So the generated output is compared between the SNH circuits as well as the DAC output in a high speed comparator. So this is it's a second stage. Coming to the third stage, based on this output of comparator, it will decide the bits, that is high or low or 0 or 1. And coming to the iterative binary search, so these whatever we are discussing previously, though this is uh, the whole process is the only once the iteration of this whole process until and analyze we get the correct output, we need to work number of times. The iterative binary search are explained as the test, compare and adjust. That's it. And finally we are getting the digital output. Conversation, timing and steps. This is the most important factor in SAR. The timing characteristics of SAR ADC are crucial for its application in real-time systems. The conversation time is directly linked to the resolution and the speed of internal components. The resolution is defined as the number of bits per second, which is that is called as a resolution. For n-bit SAR ADC, the conversion process inherently requires n comparison cycles. We don't know how many cycles are particularly to get the output, so that's why we can consider as the n-bit. The speed of conversation is primarily dedicated to two critical factors. The first one is DAC settling time and the comparator speed. DAC settling time is defined as it takes some time for the DAC when we give analog output to stabilize within a specified accuracy after its digital input changes. It's nothing but when we give some input changes to get the DAC output and stability. For faster DAC, often implemented using an advanced switch capacitor or resistive ladder network, this is also called as the RL network, to contribute and quicker conversion. And coming to comparator speed, the comparator must be fast enough to accurately resolve the difference between input voltage and the DAC output voltage within a very short time period. And delay or instability here directly impacts the overall conversion speed. So that is the reason DAC settling time and comparator speed is the two critical parts in conversion of time and steps. So as we can see the block diagram how the SAR ADC will be implemented. So first we give some analog input to the comparator, and the output of a comparator is a control signal that will be applied as SAR, and the SAR getting some binary inputs to the DAC. SAR is a getting a delivery a digital output. So whatever the output of SAR is applied to the input of DAC, the output of DAC again it will be given as the comparator as feedback. So this whole process we can conclude or tell as SAR ADC. So to tell or give a rate or what is that conclude a performance of a SAR ADC, we need to check some parameters. Those are like resolution, accuracy, and limitations. Based on these parameters only, we need to give a, this device is like this. What is that? This SAR ADC is much better than that or this. So while SAR ADC offer a compelling balance of features, their ultimate performance in subjects to inherent limitations related to their resolution and accuracy, which is critical consideration for system designers. Here this SAR ADC is resolution is 8 to 18 bits, and effective number of bits is 8 bit. And coming to the accuracy influencers, the accuracy of an SAR ADC distinct from its resolutions describes how closely its digital output represents the true analog input values. To achieve this, we need to solve or affect some factors. Those are like comparator offset, reference voltage stability, component mismatch. And coming to enhancing performance, we need to apply some various types of techniques like calibration, trimming. So yeah, based on these parameters only, we need to measure the performance of an SAR ADC. So there are some advantages or disadvantage of SAR ADC. Of course, like an electronic component of SAR ADC comes with their own set of strengths and weaknesses, making them more suitable for certain applications than others. A balanced understandable of the pros and cons is a key to proper system design. Yeah, because when we know the pros and cons only, we need to tell us okay, this is the perfect ADC for this system or not. For that purpose, we need to compulsory know what are the advantages and as well as the disadvantages. Coming to advantages, we have three major advantages like moderate to high resolution with the low power consumption and small form factor and easy integrations, constant conversation, time dependent of input amplitude. So let me give a brief introduction of each one. Coming to the moderate to high resolution with low power consumptions, it's the the range of resolution is ranging from medium to high, so that there is the adjustable of resolution is the advantage of SR ADC, because the strength of SR ADC is the different from another one. So based on this resolution, we can adjust the resolution, and it's having a low power consumption. It will be sustainable more longer time. When we have a typical time where we have no facility for re-power or reload the power consumption, so at that type of situations, so this SAR ADC is most usable. And coming to the small form factors and easy integration, so while designing this SAR ADC, the designing of integration of this circuit is a small form, so that's the reason it will be very thin and more compact and less space. And coming to the constant conversation, time independent of input amplitude, by name itself it will be indicate that constant conversation of time independent. It means that the conversation of time is a constant, the same time independent of input amplitude. So whatever the conversation time is there, so it's a independent, not dependent on the input amplitude. And coming to the disadvantages, there are two mainly disadvantages are there. The first one is the conversion speed limited compared to flash ADC. Yeah, this is the most important. And coming to the circuit complexity higher than the simple RAM ADC. So let me explain what is the conversation speed limited compared to flash ADC. When we have different ADC like flash ADC, ramp ADC. So SAR ADC is also one of the ADC. So when we compare a conversion speed, the flash ADC speed, flash ADC speed is the more when we compare to the SAR ADC, because the SAR ADC is the sequential nature. They cannot match the lightning fast and single cycling conversion of speed of flash ADC. It means that when we consider a flash ADC, it have a lightning fast as well as a single cycle conversion, but not like that when we consider the SAR ADC. SAR ADC has a multiple cycle conversion. So that's the reason the conversion speed is the high in SAR and low in flash ADC. And coming to the circuit complexity higher than the simple ramp ADC. Yeah, of course, there is a major disadvantage over the ramp ADC is the circuit complexity. When we design a ADC in terms of SAR, more complexity because they require a stable digital analog converters, more number of DACs we need to use, and precise comparator and digital logic SAR itself. But coming to the ramp ADC, there is no need any precise comparators, and it has no SAR itself. It will be dependent of another digital logic circuit. So this is the difference between SAR ADC and ramp ADC. There is a typical applications of SAR ADC. The we can also call it as real-time applications. There is a four major field applications like portable and battery-powered instruments, and in industrial control and data acquisitions, and pen digitize and touch screens, and audio and instrumentation. Coming to the portable and battery powered instruments like blood glucose meter, portable ECG machines, and wearable health monitors, or different types of portable sensor applications. Battery powered instruments are more useful. For that purpose, we need to use compulsory SAR ADC. Coming to the industrial control and data acquisitions, in a PLC is the programmable logical controllers, and distributed control systems. So these both are analog signals temperature sensors. So to achieve this designing or working, we need to use SAR ADC and pen digitize and touchscreen. Yeah, this in this application also SAR ADC provide a precise position data from resistive or capacitive touch panels, make them fundamental to pen digitize used in a graphic tablets and touch screens as well as the smartphone also. And coming to the audio instrumentation, in this audio instrumentation SAR ADC find the place in a audio equipment, example like certain audio interfaces or synthesizers and effective processors, where they digitize sound waves. They are also widely used in general instrumentation such as oscilloscope, multimeters, and etc. So there is a comparison with ADC architectures. We have different types of ADC like SAR ADC, pipeline ADC, Delta Sigma ADC, Flash ADC. The Delta Sigma ADC also we can call as a ramp ADC. So we can compare in like parameters as resolution and GSPs and speed and conversion time. So among this, all of this, SAR ADC is the best for, I think, based on this table. And coming to the recent advances and trends in SAR ADC technologies, there is a diagram that explains how SAR ADC technology is advanced based on this different parameters. Like we can see integration, calibration, speed, process. In all of that, SAR ADC is the best technology among this flash or ramp ADC. Thank you.